7.2. 7.2 is kind of awesome because it's going to give us the other part of the law of signs, and they call it the ambiguous case. So I don't know if you're familiar with that term ambiguous. You might be, I imagine you are. But if something's ambiguous, you kind of don't know what it is exactly until you start to look at it. It's something that you have to investigate in order to find out. And we'll talk a little bit about that. So we're going to do a quick recap. And what I want to do is be better than a book. A book's going to try to have you memorize, hey, if it's side angle, angle, do this. If it's angle, side, angle, do that. I just want you to remember that your whole goal is to use the law of sines. And if you can use the law of sines, then that's what you should do. But let's talk a little bit about what's happening here. So to recap, I'm looking right up top right here. To solve a triangle, we need to find the three sides and the three angles, right? That would solve a triangle uniquely if we could do that. To solve a triangle, we need to be given at least one side. There's not going to be anything we're going to figure out if we're not going to be given one side. And so the 6 possible cases of things that are given to us, if you're going to give 3 measurements, the first one is that we're given angle, angle, angle. That all those angles are given. I don't want to imply that they're equal, so I'll draw some different sides here. But if you're given the angles, if you know angle A, you know angle B, and know angle C, here there's nothing that can solve that triangle. Nothing you can do. So this goes back to a pre-algebra kind of process. You know, back in pre-algebra we did similar triangles. Similar triangles have angles that match. There's an infinite number of triangles that can be drawn with the angles being the same as we go through, and so that's why we'd get these proportional relationships between similar triangles, and we'd say, hey, this side is to this side as the other side is to the other. And so if there is just 3 angles given to you, you're not going to be able to solve that triangle. You'd be no triangle. Essentially, it's not no triangle, it's an infinite number of triangles that can be drawn with those 3 angles. And so that's that. Now remember, that comes right back to what we said second. To solve a triangle, we need to be given at least one side. And so what about if we're given one side in any 2 angles? So let's suppose we know angle A and angle B. Okay, so angle A is known, angle B is known, they're different, and we're given one side in any 2 angles, and it wouldn't matter what side. So let's suppose we're given little b. Okay, well, we'll be able to solve this using what? Using the law of sines. Now, how do I know I can do this? Doing the law of sines. If you know 2 angles of a triangle, then you automatically know C. C is equal to 180 minus whatever A is minus whatever B is. Because you know what C is, no matter which side they give you, whether it's B, you'll know the angle opposite it. Remember, that was the given one. If it was C that was known, wouldn't have mattered, because we can get the angle C pretty quickly. So anytime you're given 2 angles, it doesn't matter what side you're given, you're set because you know all 3 angles. Therefore, you always know an angle and the side opposite of it. Law of sines is going to unlock that in a heartbeat. Okay, 2 sides and an included angle. Let's take a look at what that's going to look like. So here's A, B, and C. And let's suppose we know A, apologize. Let me redraw that. A's opposite. Let's suppose we know A, and we know B, and the included angle C. Now we just know one of the angles in that triangle. Therefore, we're not going to be able to solve for any of the other 2. As we look at this, we are stuck. There's no way that we're going to be able to figure out what little c is, because this is a triangle that is not necessarily a right triangle, and therefore we can't use the Pythagorean theorem. I've watched people use the Pythagorean theorem on triangles that don't have a right triangle. They're automatically done. That relationship doesn't hold unless it's a right triangle. And so this one is going to be the law of cosines, like we saw in the previous section. Right, so this is a nice recap. What about side, side, side? There I know a side, so I should be set, right? I happen to know all 3. We saw this one in the last section. This is going to be the law of cosines again. No problem whatsoever. I'll put the S on there. And then two sides and the non-included angle. This is the one that we haven't done. This is the one setting that we haven't done, but let's look at what's happened here. Two sides. So let's suppose let me give them, since they're talking about an included angle, let me give this A, B, and C again. I'll just go in this clockwise fashion, and starting with the lower left. And let's suppose we know side A and side C, and a non-included angle, oh, sorry, I mislabeled that. I did that again. Sorry about that. Let me put A where it belongs. So it wants the non-included angle. Okay, let's say this angle right here. Well, we're going to be able to use the law of sines. Now, whenever this happens, whenever we have two sides and the non-included angle, that's what side-side angle is. That angle is out. This is what they call the ambiguous case. And so I want to direct your attention to page 300 in your textbook. I'm not going to be able to, actually, I may be able to show that. Let me see if I can show that to you. But what I would do is try to draw this, but I probably shouldn't try to draw it because I'm not the best drawer out there. And we want to show you why this is called the ambiguous case and the things that can come up. Now, all you have to do is algebraically attack it. The fact that there could be no solutions, one solution, two solutions will all make itself manifest. So don't stress about that. Let me see about quickly going over to my camera. That's not how I'm going to get that. And see how that works for us. So this is what's on page 300. See if this will come across. It should. So these are the things that could happen when you're given side-side angle. And what could happen in that very first row is that the side A that's given could be short, so short that it's never going to match to that other side with the given angle. You'll know that because as you go to find B, which would be the natural thing to find, right? Because you're given side B. As you go to find angle B, you're going to realize that the sine of B is greater than 1, which cannot happen. And therefore, you're going to find out that there's no possible triangles, and it's all just going to work out algebraically. It could work out where A is perfectly a perpendicular height, and therefore it's a right triangle. There you're going to get sine B equals 1 and find out B is 90 degrees, also one triangle. So that very first row has no triangles. The second one has one possible triangle, and the third one, now notice they're all acute. So that angle A is acute, and so you're going to get one triangle if A can extend all the way down and not be a right angle. But you could also get two, and that's what we have to solve for. We get to figure out whether there's 2 or 1 in those situations. Now if the angle is obtuse, there's either 0 or 1. And again, you're going to know the 0 case because when you solve for the B, it's going to be greater than or equal to 1. The mental picture you want to have is that the side length's not long enough to connect with that big angle. Or it could connect, but there's no way it could do 2. With that obtuse triangle, there's no way it could happen twice. Acute, because the angles add up to be 180 in a triangle, could happen twice. And so we're going to go through problems and decide whether there's no solutions, one solution, or two solutions, and find those solutions if there's 1 or 2. So there's some work involved, but this is why we wanted to hold 7.2 off until after we saw the law of cosines. Okay, I'm going to switch back to the notes coming through there. So hopefully that was able to be seen. You can study that on page 300. You can see the narrative that's there. It's described pretty well. And what you're going to have is some examples that we're going to do together. Sorry that the notes went off on you there. Had a feeling that that might happen. So as we come down here, let me just get to this guy. and erase, and you can see what we're going to do next. We're going to do a bunch of examples. So I'm going to stop this initial video, that way they don't get too long, and I'll call this one the introduction, and then we'll look at some of these examples. And notice that they're all tied directly to homework problems that you're going to be doing. And so they are nice. We'll see the times when there's one or two. You'll have them on the exam. You'll know exactly how to navigate through them, because not only have you watched these videos, but you've studied the cases that are here in 7.2, in 7.1, and 7.3. So don't skip the big resource that's your book as well. However, these videos should give you examples exactly like the ones that are found in the book.